Hey everyone, and welcome. Let's talk about something we all deal with, sample size. But today, we're going to completely reframe it. Forget thinking of it as just some tedious checkbox you have to tick off. We're going to put it right where it belongs, at the absolute heart of your research question.
Honestly, this quote, it's the key to everything. For way too long, we've treated sample size like this annoying math problem we have to solve just to get our protocol approved, right? But what this quote nails is that it's actually the complete opposite. It's the bridge that connects your brilliant idea, your hypothesis, to the actual data you need to see if it holds up. You could even say it's how you put a number on your own curiosity.
Okay, so if it's not the last step, where on earth do we start? Well, we start with the why. What is the fundamental point of your study? Before you even glance at a formula or punch a single number into a calculator, you need to be able to say crystal clear with one single verb what you are actually trying to do.
Seriously, I want you to just pause for a second and think about your own work. Maybe it's that thesis that's keeping you up at night or a new clinical trial you're designing. What is the one core question you're trying to answer? Because the clarity of that question, that's the bedrock for a rock-solid sample size calculation.
And what's so cool about this is that these verbs, they're kind of like a sorting hat for your research. Think about it. Are you trying to estimate something, like the prevalence of hypertension in a population? Or are you setting up a trial to compare a new drug to a placebo? Or maybe you're doing a case control study to associate a certain risk factor with a disease. See? Each one of those verbs sends you down a totally different statistical path. So, once you've nailed down your verb, the next part is actually super logical. All you have to do is match that verb to its formula family. It's really just about using the right tool for the job. I mean, you wouldn't use a hammer to listen to a heartbeat, right? Well, in stats, picking the right formula is just as important. This table lays it all out nice and clear. If your goal is to estimate something like prevalence, boom, you're using a single proportion formula. If you're running a trial to compare two different groups, you'll be looking at a formula for two proportions. Trying to associate an exposure with an outcome, maybe in a case control study, that's going to be based on an odds ratio. You see the pattern here? Your objective drives the method. It's never the other way around. All right, so you've got your objective, you found the right formula family, awesome. But a formula is useless without its ingredients, its inputs. And listen, these are not numbers you can just pull out of thin air. Every single one is an assumption, and you have to be ready to justify and defend each one in your protocol. This is where you really build the case for your research. And here are the usual suspects, the things you'll need to figure out. You've got to decide on your acceptable error rates. That's your alpha and your power. You've got to specify the effect size, like how big of a difference would actually matter in the real world. You also need a good estimate for the variability in your data, and you can usually find that by looking at older studies. And don't forget, you have to plan for the real world, like patient dropouts, and build that into your number. Let's dig into the two really big ones. First up, we have alpha. You probably know it as the p-value threshold. This is basically your risk of a false positive. Think of it as crying wolf. It's the chance you'll get all excited and conclude there's an effect, say that your new drug works, when, whoops, it actually doesn't. And that's why, by convention, we try to keep that risk really low, usually at 5%. Then you have power, which is pretty much the flip side of the coin. It's the probability that your study is strong enough to actually detect an effect if it's really there. So the big question is, if a drug genuinely works, what are the odds your study will be able to see that? Because an underpowered study, that's a massive waste of everyone's time and money. You could miss something huge. Imagine a promising new drug for hypertension. In a small trial, it doesn't show a significant effect, so the drug gets tossed aside. But maybe the real problem wasn't the drug at all. Maybe the study was just too small to pick up on that modest, but still clinically important 5 millimeters of Hg drop in blood pressure. See? That's why we aim for 80% power, or even higher. We want to give these good ideas a real, fair shot at proving themselves. So, let's recap. We started by boiling down our study to a single verb. Then, we mashed that verb to the right family of formulas. And then, we talked about defending all the key inputs that actually bring that formula to life. What this all adds up to is a complete shift in mindset. We've been asking the wrong question all along. And if you take one thing away from this, let it be this. Stop asking, what's the sample size? Instead, ask, what claim do I need this sample to support?
Your sample size isn't just some random number you need to hit. It is the literal foundation that your entire scientific claim is built on. It's the amount of proof you need to convince not just your colleagues, but also yourself that what you found is real and that it matters. So figure out the claim you're trying to make, figure out how much evidence you need to back it up, answer that, and you found your sample size.